Hi students, this is Sheikh Majeeth. Welcome to this session on electric field due to a dipole. This is a very important question and it is a very big derivation. So please listen carefully, but it is very easy derivation and you can score very good marks in this area, right? So what we are going to see, we are going to see electric field due to a dipole. E is electric field. So we are going to find what is electric field due to dipole. This is derived by taking two conditions into account. One is electric field due to dipole at axial axis, at points on axial axis, at points on axial line or axial line. Second one, electric field at points on equatorial plane. Second one is equatorial, EQA, equatorial plane, right? So we have to derive these two electric field due to these two conditions, right? One is first we have to find what is the electric field at points on axial line. What is the electric field due to a equatorial plane, right? So first we find what is the electric field due to point on axial line. So we must ask what is axial line, right? So first derivation, E due to points on axial line, right? So we know dipole is a two equal and opposite charges separated by a small distance, right? Let us assume it is 2a, right? What is axial line is? Axial line is nothing but a line which is connecting the center of the two charges. We know the center of this charge is this one, the center of this charge is this one. If you draw a line from the center of one charge to center of another charge, then that line is known as axial line. So you can extend up to infinity from this side and this side. So this line is axial line, right? Next we have to find what is electric field due to a electric dipole where points lying on equatorial plane, right? Second condition. What is equatorial plane is? It's a plane that must be perpendicular to axial line and pass through the center of the dipole. This is the center, right? So this is one dipole, this is another dipole, center is this one. The equatorial plane is a plane which is perpendicular to the axial line and pass through the center. So exactly, let us assume that it is appearing like this. That means what? In this center, you assume that you are putting one plane on the center, right? So we cannot put a plane. It is actually this plane is located. This is the direction, right? So it is located. You draw one line in the center. You put your notebook, right? That is assumed to be a equatorial plane, right? So in this point, suppose if your field point lies at here, what is the electric field we have to find? It is electric field due to dipole where points lie in the equatorial plane. Suppose if your points lie at here, it is like finding the electric field due to a dipole where points lie on the axial line. Is it okay? So first thing we have to find is electric field due to axial line, right? So first we draw one diagram. First we draw dipole. Let us assume that dipole is lying here. Okay, I draw somewhat big. Minus, plus. This is minus, plus. Where these two dipoles are separated by a distance 2a. Center is O, origin. This distance is a. This distance is also a. Total distance 2a. Right, so we know axial line is this is the axial line. We have to find electric field due to a dipole at points on the axial line. Let us assume my point located here. So I have to find electric field at this point. Let us assume this point is A, this point is B. Charge, negative charge located at point A, positive charge located at point B, and I have to find the electric field at point C. So here only I have to find the electric field, right? Okay, now we know that dipole moment always goes from negative to positive. So this is the direction of P vector, right? So the direction of P vector, right? Okay, so since it is positive charge, and we know that electric field lines will move from positive charge to negative charge. So this is the direction of E, right? So this goes here. So it is E minus, right? This direction it is going E plus. Fine. Sorry. Right? Why? So because so here you see I draw E minus in this direction, whereas E plus goes this direction. The reason you know that electric field lines always goes away from positive charge. So this positive charge, so electric field lines will go away for positive charge. So E plus will be moving away. Whereas for negative charge, electric field lines goes towards negative charge. So that's why I put E minus in this direction. This is very, very important one. So in the exam, we have to draw the direction properly. And also we assume that the distance from center to the field point is R. C is a point where we are going to find the electric field. So we call that point as a field point. So distance from C to O, that is center of the origin or center of the dipole is O. So distance from O to C is R. Clear? So this is very, very important. Now we derive. Now first we derive what is the electric field at point C due to the positive charge plus Q. So I write as E plus. E plus is nothing but electric field at point C due to the point charge Q. We know that electric field is given by Q by 4 pi epsilon naught R square. Here instead of Q we are having plus Q, no problem. Q by 4 pi epsilon naught R. What is R square? R is the distance between the source and field point. Here field point is C. What is the center? Center is O. So right, sorry, source is lying here at R, right? So positive charge to field point C. So from center to C is R, clear? But we don't know what is the distance between these two. Here to here we don't know, clear? But I know from here to here the total distance is R. But I know one more thing, here to here distance is A. So total distance is R. This distance is A. That means this distance must be R minus A. Suppose R is equal to 100 kilometer. Let us assume A is equal to 10 kilometer means what about distance? 90 kilometer. You know, right? So R minus A. Clear? So this is the way. So distance from point positive charge to center is R minus A. So Q by 4 pi epsilon naught R squared. Instead of R squared, I have to substitute R minus A whole square. Right? Sorry. Where will be the electric field? Electric field lying along this direction, E plus. I told E plus will be moving away. So it is in the direction of P vector because P vector also in the same direction. So this is scalar parameter. Up to this scalar parameter. How to make a scalar into vector? We have to multiply with the unit vector I told. So you make unit vector is P cap. Right? Okay. Next we find where P cap is the dipole moment, that is from minus Q to plus Q, that we know already. Similarly, the electric field due to negative charge is given by E minus, that is also Q by 4 pi epsilon naught R squared. R is the distance between the negative charge and the field point. You see from center to C, the distance is R, but my charge is located here. So from here to here, the distance is A. So this distance is R, this distance is A. So what is the total distance? R plus A, right? So R squared, instead of R, we have to substitute R plus A squared. This is a scalar, but electric field is a vector, so unit vector is P cap. Fine. So this is very, very important, right? So who is producing the maximum field? Whether E plus will produce maximum field on C or E minus will produce maximum field on C. I told in the electric field line class, electric field is very strong nearer to the charge and weak when we move away from the charge. So you see point C is closer to positive charge, but it is far away from negative charge. So electric field due to positive charge will be strong, but electric field due to negative charge will be weak. So the length of the electric field vector should be more for positive charge, right? So that is the way you have to draw. Next, so we find what is the total electric field. E total is equal to E plus vector plus E minus vector. What is E plus? 1 by 4 by epsilon naught. See, in E plus and E minus, in both the case, 1 by 4 by epsilon naught is common. So I take that one is outside. This is Q by 4 by epsilon naught. Sorry. Q by R minus A squared into P cap. See, I have to remind you one thing. This is P cap, but this P cap is minus because here I have to put minus P cap. Why I am putting minus P cap? See, P is going from this direction, going to this direction, whereas E minus is opposite direction. So for that we have to put minus. So it is minus P cap. So when I put this one, what is happening? Okay. So Q by R minus A whole squared minus Q by, it is P cap, Q by R plus A whole squared into P cap, right? Okay, so next what we have to do, we have to simplify. So E total is equal to, Q is common, so I take Q also outside, Q by 4 by epsilon naught 1 by R minus A whole squared minus 1 by R plus A whole squared, right? P cap also common, so I take it outside. Now I simplify. Q by 4 by epsilon naught. Clear? So what we have to do? We have to simplify. Take LCM, right? So R minus A whole squared into R plus A whole squared, cross multiplication. R plus A whole squared means R squared plus 2AR plus A squared minus of this fellow will come here. So R squared minus 2AR plus A squared, right? So R squared cancel, A squared cancel. What we get is 1 by 4 pi epsilon naught, right? So what I have here, I have 2AR, here also minus of minus 2AR plus 2AR, so 4AR, right? So it is 4AR divided by R squared minus A squared whole squared. Why? Because R minus A, I can write R minus A squared is nothing but R minus A into R minus A. R plus A is nothing but R plus A into R plus A. So A plus B, A minus B is equal to A squared minus B squared. So this will create 1 R squared minus A squared. This also will create 1 R squared minus A squared. So that's why we are writing like this. So we got this. So what is the electric field? Total electric field E total is equal to 1 by 4 pi epsilon naught divided by 4 RA divided by R squared minus A squared whole squared P vector. Clear? Now suppose if we consider R, the distance from the center of the dipole to the field point is greater than distance between two dipole center to the charge A, means what happens? R is far greater than A. So R is far greater than means what will happen? This A is negligible. So you can remove that 1 by 4 pi epsilon naught, right? 4 RA, right? 4 RA into P vector divided by this A will be removed, so R power 4, because A is cancelled. Why we are cancelling A? Because we are assuming that A is very very small. Suppose if R is 100, A is 0.001, so we can neglect. So R cancelled, so it will be R cube. So that is equal to E total is equal to 1 by 4 pi epsilon naught 4 AQ divided by R cube into P vector, right? So we know that from a dipole moment equation, dipole moment is equal to 2AQP vector P cap. This we studied already in a dipole class. If you are having doubt, please go to dipole class. So 2AQP is equal to P vector is equal to what you call, it is P vector. So if you substitute this equation into this one, it is 4AQP. So 4AQP vector is equal to 2P vector, because 2AQP is nothing but P vector, so remaining is 2, so it is 2P. So instead of 4AQ, substitute 2P. So E is equal to 1 by 4 pi epsilon naught 2P vector divided by R cube. So this is the electric field due to dipole where the points lie at axial line, right? So this equation is very very important. You see, E varies in terms of R cube, whereas we studied in point charge E is equal to Q by 4 by epsilon naught R square. Here it is R cube, right? So this point we have to use later, right? So this is very very important derivation. We completed only one part. We go to the next part now, right? Okay, now we study electric field due to a dipole at a point on the equatorial plane. I told already equatorial plane is the plane which is perpendicular to axial line and passes through the center of the dipole, right? So first we draw dipole. This is minus, this is plus. Clear? So connecting these two, the center is O. This point you consider as A, this point you consider as B, where I have to find in the equatorial plane. Equatorial plane is a plane which is passing through a center. So I draw like this, right? It's going like this. Fine, right? Okay, so let us assume my point is located here. Fine. Okay. The distance between the field point C and the center of the dipole is R. This distance we consider as R. Right? I have to find the field at point C. So what is the electric field created by negative charge? Here it is negative charge. We know that for a negative charge, electric field lines goes towards electric charge. So it will be like this, arrow mark in this direction, right? But for positive charge, it will be moving away from the direction. So it will go like this. Clear? Because for positive charge, the electric field lines move away. So what is the total electric field? We know the vector sum. We have to add these two. Clear? This is E plus, right? This is minus E minus direction. So total electric field will be in this direction, right? We have studied vector addition. Clear? Okay. So let us assume this is point charge plus Q, this is point charge minus Q, right? The distance from center of the dipole to the negative charge is A, center of the dipole to the positive charge is another A. Total distance is 2A. The angle is theta here, right? So this is also theta. Now, okay. Now what we have to do? We have to study one important thing. Fine. Okay. So this you see that the positive charge is the electric field due to positive charge goes like this. We have seen in the diagram here. Similarly, negative charge, it goes like this. This is the center line. So negative charge goes like this, right? This is the sum, total electric field, ET. This is E minus, right? So I have to find what is ET. Here you see, we know if this angle is theta, I think the diagram is changed. If this angle is theta, right? This angle is theta means the same angle only it goes here. So that angle also must be theta. For example, so it is coming here. So it is theta means here also it should be theta, right? So similarly, it is theta means here also it is theta, right? Okay, now what we have to do? We know that this side and this side will be equal. This green side and this green side will be, so this side and this side will be equal. This side and this side will be equal. So this is theta. Let us find cos theta. Cos theta is equal to, here let us assume this black distance is x. This is adjacent side. Adjacent side divided by hypotenuse. Hypotenuse is this distance E plus vector. So what is x? X is equal to E plus cos theta. Clear or not? Yes. So this distance is E plus cos theta. Similarly, you draw here, I draw, this is theta, right? So we know that this is E minus vector. Clear? So let us draw one line to here and here. This is a vector addition, right? So this line and this line have same magnitude. This line and this line have same magnitude. So I want to find this length, right? Or this length for this. Okay, so sine theta is equal to, for this opposite side, let us assume this is x. If this is x, this is also x. Sorry, let us assume y. This is y, this is also y. So y by hypotenuse E minus vector. So y is equal to E minus sine theta. So this length is E minus sine theta, right? Similarly, if you find cos theta, this length will be cos theta. Here E plus sine theta. Clear or not? So what we get is, if you are having like this, Clear? So this is theta, right? Adjacent side is e plus sine theta. This is e minus sine theta. This is theta, right? This is e plus cos theta. This side e minus cos theta, right? But what is this? This vector goes this side, this vector goes this side. Both are going in the opposite direction. So they will cancel each other. Clear or not? So what is the only factor contributing to this equation? E plus cos theta and E minus cos theta. So what is my total electric field? E total is equal to E plus cos theta, right? Magnitude. So it is a vector quantity. So we have to find in which direction P is moving. So because unit vector is a, what is the unit vector? Unit vector goes from negative to positive. Sorry, dipole moment goes from negative to positive. But here you see dipole moment goes from negative to positive. So my negative charge is located here. See, my negative charge located here, positive charge located here. So dipole moment will be in this direction. But as per my E total is moving opposite direction. So this is P cap means E will be acting in minus P cap direction. So what we have to do? So it is minus P cap. So put minus P cap. Similarly, E due to negative. So that is E minus E cos theta P cap. Again that is also minus. Right? So it is E total. Clear? Now we find what is the magnitude of E plus. E plus, modulus of E plus is given by, because both are lying at the same distance from dipole. You see this is minus location, this is plus location, C is located here. Here to here, same distance. It is the center, right? So this C, this A, B, from A, C is the same distance. Like A to C is same as B to C. So AC is equal to BC. So E plus is equal to E minus. Because E plus is nothing but electric field due to positive charge. E minus is nothing but electric field due to negative charge. Since the distance is same, electric field is also same. So what is the distance? E is equal to Q by 4 pi epsilon naught. So 1 by 4 pi epsilon naught Q, right? What is the distance? We know this distance is A. This distance is R. So what must be this distance? Use Pythagoras theorem. This is A, this is an adjacent side, opposite side. So this is A squared plus R squared. So distance between A and C is R, A squared by A squared plus R squared. So R squared plus A squared. Q pi 4 pi epsilon naught R squared. Clear? It is magnitude. So that's why I don't put vector quantity. So E plus and E minus we found. Substitute that E plus and E minus value in this equation. So if you substitute that, E total becomes is equal to minus 1 by 4 pi epsilon naught into Q divided by, right, R squared plus A squared into P vector. Fine. Okay, so that is my total electric field. Now we know that from the diagram cos theta is equal to, here you see what is cos theta, right? So this is theta or this is theta. Cos theta is given by cos theta is equal to adjacent is A only. So A by hypotenuse R squared plus A squared. So A by R squared, square root of R squared plus A squared, right? So A by root of R squared plus A squared. Instead of, right? So what we have to do, instead of, we know that it is 2q cos theta, sorry, it is 2q cos theta. Why it is 2q cos theta? Because in the e plus v minus we found it, this cos theta, so totally 2q cos theta. So 2q cos theta, we found what is cos theta. Cos theta is given by a by root of r squared plus a squared. A, that is equal to a by r squared plus a squared, root means 1 by half. Clear? So substitute this cos theta. So what is my E total? E total is equal to minus 1 by 4 pi epsilon naught, right? 2q cos theta, right? So 2q, 2q, instead of cos theta, I substitute a r squared plus a squared in the equation, original equation. You see here already I have r squared plus a squared. This is multiplied by 1 by root 2. So it is already I have r squared plus a squared. This again I multiply by r squared plus a squared half. So it will become r squared plus a squared 3 by 2. Fine. So now what we have to do, 2qa divided by r squared plus a squared 3 by 2. Then we substitute p vector is equal to 2qa p cap. Is it right? We know this already. So instead of 2qa p cap, you substitute p vector. So E total, this is E total, 2qa, sorry, I missed p vector. So 2qa p vector, I put as p vector. So it is p vector divided by 4 pi epsilon naught r cube, right? Minus. We have to put minus. Why I remove a? I consider r is far greater than a. Like we consider it for axial line, we consider r is far greater than a. If r is far greater than a, I can neglect this. Yes or no? So it will become r cube. Clear? Because r squared into 3 by 2. Yes? Or I will, oh shit. You see, r squared plus a squared power 3 by 2. I neglect a, so it will become cancelled. So r squared 3 by 2. So 2 cancel, it will become r cube. Right? So that's why it is minus p by 4 pi epsilon naught r cube. Right? So it is very important. It is the electric field due to a dipole at equatorial plane. Already we derived electric field due to dipole at axial plane. We write this again. So what is electric field due to equatorial plane? It is equal to E total minus P by 4 pi epsilon naught r cube. Whereas for electric field due to axial plane, it is, sorry, E is equal to what? 2p vector divided by 4 pi epsilon naught r cube. This we derived already. So it is axial. This is equatorial. Equatorial plane, axial line. Right? You compare both the equation. You see that the left hand side, what is the relationship between the left hand side and the right hand side? It is 2 simple p, right? It's simple p where it is 2p, right? So what we are understanding from this, the electric field at points on the dipole axis, it is axial line, right? It's the electric field at points on the dipole axis 2 times the magnitude of electric field on the equatorial plane. Because it is equatorial plane, it has only 1p, it has 2p. So electric field due to axial line is twice the amount of electric field due to the points on the equatorial plane. And also we can see that this is minus p, this is plus, right? So direction indicates the direction of electric field at points on the dipole axis is directed along the direction of dipole moment vector. Here you see it is axial plane, so it is going along the direction of plus. It is going opposite direction, minus, right? So it is going opposite in the equatorial plane. So that is another important difference. Clear? Next one, you see that equation, electric field due to dipole varies 1 by r cube. Here it varies also 1 by r cube. So what we are understanding, E due to dipole varies inversely proportional to the cube of the distance between the field point and source. Whereas electric field due to point charge, we know that it is q by 4 by epsilon naught r square. It is square, it is cube. So who will decay fast? R cube will make to 0 faster than r square, because when you substitute r is equal to 2, it is 1 by 4. But when you substitute r is equal to 2 here, it is 1 by 8, which is very less. 1 by 8 is very less. So electric field due to dipole will decay very fast compared to electric field due to point charge. What is the another reason for this? In point charge, we are having only one charge, whereas in dipole we are having two charge, that two plus and minus, opposite charge. So the field created by one charge is cancelled by the field created by another charge fast. So that's why electric field due to dipole dies very fast compared to electric field due to point charge, right? Okay, now we have these two equations, right? E due to axial plane and E due to equatorial plane. So what we understand from that, see, E varies as 2p divided by 4 pi epsilon naught r cube, this is axial, minus p by 4 by epsilon naught r cube is equatorial plane, right? So these two equations we derived with the assumption that r is far greater than a. What is r? The distance between the center of the dipole to the field point, whereas a is the distance between the center of the dipole to the charge. With this assumption only we have derived these two equations. But if the distance between the two dipoles approaches 0, that is, distance between two dipoles is 2a. If it becomes 0, with the assumption that it becomes 0 and q tends to infinity, what happens? We know dipole moment is 2aq, the distance between the dipole and the charge. So it will become finite, because 2a is closer to 0, q is closer to infinity. So when you multiply any big number by a very, very small number, the result will be a small number, that is a finite number. So 2aq becomes finite. The dipole which is satisfying this condition is known as point dipole. So we have to remember this, point dipole. Point dipole is a dipole where the distance between two charges approaches 0 and the value of charge approaches infinity, right? So for such a dipole, right, the two equations we derived, axial and equatorial plane equation, no, those two equations are exactly same, not like this, one is plus one, the other one is minus, no, that condition will not be applicable for point dipole, right? So that's all about this session, right? If you are having any doubt, you can ask me in comment section. Here I have given some questions to test your understanding. Try to answer this question in comment section. I will clarify all your doubts and we will discuss the answer in the comment section also. Thank you.